Dairy mapping, summary of sources of dairy waste and byproducts, presents the findings of a mapping project conducted between November 2015 to October 2016 by WRAP in collaboration with Lucid Insight. We are grateful to Arla Foods for their support in this project and for providing their time and insights. This presentation provides information about why this project was undertaken within WRAP's Courtauld 2025 programme. It discusses the scope of the project, how the mapping exercise was carried out across different dairy products, and presents the key findings of the project which identified the byproducts and waste generated, their sources and the factors that caused such losses, those that were subsequently prioritised for further investigation, and the opportunities for getting more value from these materials. This section presents the background and methodology. As shown on the schematic to the left of the page, Courtauld 2025 ambitions will be achieved through minimizing the waste that are produced, through better design, improved supply chain efficiencies, and changes in consumer behavior. However, it is recognized that even when waste minimization strategies have been implemented, there will still be the generation of unavoidable byproducts and waste within the manufacturing process. Previous studies carried out by WRAP have identified that dairy, bakery, fresh produce, and drink sectors have the greatest opportunities to get more value from their byproducts and wastes. The food waste hierarchy highlights that where wastes are avoidable, they should be at the top of the hierarchy through prevention measures. Where there are unavoidable wastes, there are opportunities to move the material up the hierarchy to find other higher value markets. The dairy sector produces a plethora of products from one main ingredient, which is milk, manufactured through different processes. 16 key product types across 13 sites were identified and investigated, and only byproducts and waste generated within the manufacturing process were included within the scope of this project. Waste generated before entering or after leaving the dairies and packaging were not included. The byproducts and waste mapping process comprises of 4 stages. 1. Identifying material flows. 2. Identifying unavoidable wastes. 3. Prioritizing hotspots where significant volumes of byproduct or waste are generated. And 4. Characterizing priority wastes and byproducts. Stages 1 and 2 involve visiting the dairies and reviewing the entire manufacturing process to understand and record what byproducts and waste are generated. This was achieved initially through reviewing process flow diagrams and then running through the process during site visits and a walkthrough with on-site personnel. At the same time, byproducts and waste were characterized as either being avoidable and could therefore be minimized or unavoidable. Current disposal routes were also recorded. This information was then converted to a material flow analysis as seen in the slide. In this case, readily available software, STAN, Substance Flow Analysis, was used to enable a visual representation of material flow through each stage of the manufacturing process. This slide presents part of the MFA for milk. The raw material enters the process and at different stages byproducts and waste are generated. For example, as milk enters the separator, excess cream and desludge are generated. The cream is then used and exported off-site as food product, but the desludge is typically sent to water treatment as effluent or to landfill. Once all 16 products had been mapped, almost 200 waste flows were identified. Quantifying these streams was impractical, so a method of prioritization was required in order to select up to 5 products to investigate further. To do this, a workshop was held with Arla personnel, and all waste flows were reviewed, based on quantity generated, concentration within the waste stream, and cost of disposal. Each waste stream was then plotted on a prioritization matrix, as can be seen, given a score, then the 5 highest scoring waste streams were prioritized. When collecting data from personnel, specific questions need to be answered when characterizing byproducts and waste generated through the manufacturing process. This section presents the findings of the project. In total, 32 unavoidable wastes and byproducts were identified and generated across 16 product types. These are not reused in the process and therefore need to be removed from the site for disposal. As can be seen, they are grouped across 4 stages of the manufacturing process, from intake through to store and dispatch. Most byproducts and wastes are generated during the processing stage. Here are some key factors that impact losses, some of which could be minimized, others could be taken forwards to add value to. Following the process of prioritization, the top 5 products were prioritized for further investigation and quantification. Out-of-spec and minimum life on receipt rejects are generated within fresh milk product lines. Out-of-spec refers to quality issues of the milk product where milk does not meet specifications and is therefore discarded. In the case of MLOR rejects, milk may be rejected where there are insufficient days. These generally go to drain, AD, or animal feed. Separated desludge is also generated in the fresh milk production line and is the liquid backflush residue arising from the process of separating cream from the milk. This generally goes to effluent unless there is an on-site AD plant that can take the material. Salty whey is produced during hard cheese processing. It is separated from the curds following salting during draining and forming processes. Treated whey may be further processed into whey products such as whey protein concentrate and whey powder. However, this option is currently not available to all sites, and flows from salty whey may be collected separately or mixed with other liquid byproducts and sent directly to drain, or collected in segregation tanks for removal from site or for further on-site treatments. Retained samples are examples of the final packaged product taken from each run and kept in cold store until end of life has expired for reference or testing in case of issues or complaints. Acid whey is produced during cottage cheese processing and is collected from the washer drainer following spray washing of curds with water. This section presents the findings from the project in terms of the opportunities for adding more value and the extrapolated total volume of product in the UK based on data captured from the participating dairies and from published data. Despite out-of-spec milk and minimum life on receipt rejects scoring highly in the prioritization stage, it was found that the actual incidence of rejects was very low. The chilled supply chain means that if MLOR rejects occur, they most often can be returned and redistributed without losses. The table shows that 0.03% of milk intake is wasted as out-of-spec milk or MLOR rejects. Separated desludge is potentially a rich resource with high nutrient value containing proteins. Yet at many UK sites, the material is not being utilised in any form, but is going to drain or anaerobic digestion. 0.14 to 0.2% of the 6.76 billion litres of milk intake is wasted as separated desludge. This equates to 13.5 million litres, costing the UK industry up to £845,000 per year. Typically, acid whey has lower values for lactose and proteins than sweet whey, which is already valorized for these components. Residual curd fines and the acid pH can cause problems for acid whey utilization. The UK manufactures up to 81,000 tonnes of cottage cheese, which produces 55,600 tonnes of acid whey. This is a cost of £55,600 to the industry per year. There are already routes to valorise salty whey. Although there are opportunities to get more value, not all sites in the UK are able to do this. Hard cheese produces up to 114,000 tonnes of salty whey per year. In comparison to whey and desludge, the volumes of hard cheese retained samples generated are low, however the composition is nutritionally high. This is an example of low-volume, high-potential material. Of the 341,000 tonnes of hard cheese produced, between 424 to 850 tonnes is generated. No costs were obtained for this byproduct. This section summarises the valorisation opportunities and final comments. The table below summarises the potential opportunities for getting more value from byproducts and wastes. Where the cells in the table are shaded green, there is greatest potential. Based on all three criteria being high, separated desludge showed greatest potential, whereas hard cheese retained samples showed least potential. The other byproducts were of similar potential. Listed in the final column are the recommendations and are based on the findings from site visits and dairy operators alongside conversations with stakeholders within the sector. This slide provides a final comment on the project and its findings. To contact WRAP about this work and to find out how we can support business get more value from byproducts and waste, contact us by email or visit us at our website at wrap.org.uk/adding value.